So here is another video discussing measures of variation. In this video, I'm also going to take a moment to discuss measures of center, which was learned in the previous section. The number of meat products sold at Teats Food Store for 15 randomly selected days in the month of September is selected below. So 162 meat products, 109, 250, 210, 199, 381, 222, 228, 343, 591, 169, 198, 208, 454, and 250. Does this data set represent a sample or a population? Well, it's 15 randomly selected days. So it's not the entire month, it's 15 randomly selected days. So we're dealing with a sample here, or a sub-collection of the population. So this data set represents a sample, which is always important to note. And so I'm going to go straight to the TI-84 Plus calculator. For time's sake, I already have the data values pre-populated into my calculator, but you have to enter them into a list. So press the Stat button. Press Enter to open the Edit menu. And here, I have all 15 values listed in my calculator. So to calculate measures of center and measures of variation, press the Stat button, go over and select the right arrow key to highlight Calculate, press Enter, and I entered my data values into list 1, so press second. And for me, I press 1 because I'm dealing with list 1. But you press 2 or 3 or 4 or 5 and so on if you need to. 1. Then scroll down, frequency list, leave blank, press calculate, press enter. And so the very first thing is my average or my mean. So on average, out of the 15 randomly selected days, they sold 264.9 meat products. So that's the very first question. What is the mean number of meat products sold in September at Teats Food Store? Well, since it's a sample, we're dealing with the sample mean. The notation would be X bar. One way to do it is to add up all the data values and divide by the 15 randomly selected days. You end up with the same value. Or use the calculator and it gives you it here. What is the median? Well, to do it by hand, you have to list your data in order. You would list it from smallest to largest, or largest to smallest. There's a 15 values, so the middlemost number would be the median. So the middlemost number is here, 222, that's the 8th value, and so the median is 222. If you scroll down in your calculator, it gives you the median right here. What is the mid-range? Well, the mid-range, you add up the maximum data value plus the minimum. Take that sum and divide by 2. So the maximum number of meat products sold was 591, plus the minimum number sold was 109. Take that sum, which is 700, divide by 2. You end up with 350, is the mid-range of the data set. Find the mode. Well, remember, it's helpful to order your data. Your calculator will actually do that for you. Press the Stat button, scroll down, press Sort A, which means sort ascending, press Enter. Second L1, press Enter, and go back to the Stat button to open up the Edit menu, and the data is in order. This is a helpful way to identify which values repeat. In this case, if you continue to scroll down, you see that 250 is the only value that repeats. Therefore, there is one mode, 250. So measures of variation, which is what this section is all about. Everything in the previous questions dealt with measures of center. Measures of variation or the standard deviation, the variance, and the range. So the calculator gives us that as well. If I go back to the Stat button, select the right arrow to highlight Calculate, one variable statistics, and I scroll all the way down to Calculate. The first question deals with standard deviation. It's going to be either this number here, 126.627 and so on, or it's going to be this number here, 122.3342, so on. That's why it's important to note, are you dealing with a sample or a population? In this case, we're dealing with a sample, so you have to select S for the sample standard deviation. So the standard deviation is 126.6 meat products, rounding to 1 decimal place. Find the variance. Well, to find the variance, you simply take the standard deviation, which we found here, 126.6279515. You take that number and you raise it to the second power, or you square it. So when you do that, you get 16,034.6. So this is your variance. Find the range. Well, you take the maximum data value in your set, subtract off the minimum data value. So 591 minus 109. The range of the data set is 482. Next question. Use the range rule of thumb to find the limit separating values that are significantly low or significantly high, then determine if selling 525 meat products is significantly high, significantly low, or not significant. Well, recall, we found up above the average, or the mean, was 264.93. The sample standard deviation was 126.6. The range rule of thumb gives us a range for significant values and not significant values. The range rule of thumb says if you got 2 standard deviations from the mean, that's going to give you a range of significant versus non-significant values. So if you start at your average and subtract 2 standard deviations, so our average was 264.93, subtract 2 times your standard deviation, which is 126.6, you end up with 11.73. So what this is saying is that 11.73 or less is considered a significantly low number of meat products. Well, if you start at your average and add 2 standard deviations, so 264.93 plus 2 times the 126.6, you end up with 518.13. So 518.13 or more meat products is considered a significantly high number. Any number of meat products between the 11.73 and the 518.13 is not a significant number of meat products. So the question asks, is selling 525 meat products significantly high, low, or not significant? Well, if the average is 264.93, 525 is way higher than that number, so it's definitely not a significantly low number. Since the 525 falls above the 518.13, we say that if they sell 525 meat products, that is considered a significantly high number of meat products. So another example. My statistics course took their first exam, and the scores are normally distributed. The mean score for the exam was 75, and the standard deviation was 6. Using the empirical rule, what percent of students scored between a 57 and a 93? Well, the empirical rule tells us 3 things. If you go out 1 standard deviation from the mean, approximately 68% of the values fall within those two numbers. If you go out 2 standard deviations from the mean, approximately 95% of the values fall within those two numbers. That's the range rule of thumb. And the third thing is if you go out 3 standard deviations, approximately 99.7% of values fall within those two numbers. So the further you go out from the mean, the more values lie within those two numbers. So basically, the empirical rule says if you start at the average here at the center, well, my average or my mean was 75, and you go out 1 standard deviation. So you subtract 1 standard deviation. So 75 minus 6, which is 69. And you add 1 standard deviation, 75 plus 6, you end up with 81. So 69 and 81 is a range of values where about 68% of the class scored between those two numbers. That is 1 standard deviation from the mean. If you go out 2 standard deviations, so 75 minus 2 times 6, or 75 minus 12, you end up with 63. If you add 2 standard deviations, that's 75 plus 12, which is 87. So going out 2 standard deviations, you end up with 63 as a lower number and 87 as a higher number. So what this is saying is about 95% of the class scored between a 63 and an 87. If you go out 3 standard deviations, so you subtract 3 times sigma, so 75 minus 18, you end up with 57. Here, you add 3 standard deviations, so 75 plus 18, you end up with 93. So if you go out 3 standard deviations from the mean, then about 99.7% of the class scored between those two numbers. So the question asks, using the empirical rule, what percent of students scored between a 57 and a 93? Well, in order to get to the number 57 and the number 93, you have to go out 1, 2, 3 standard deviations from the mean. So that means about 99.7% of the class scored between a 57 and a 93. So using example 3 above, would you say that scoring an 84 is a significantly high, a significantly low, or not a significant score? Well, the range rule of thumb says if we go out 2 standard deviations, so if we subtract 2 standard deviations, that's here, 63. If we add 2 standard deviations, that's here, 87. Would 84 fall in between those two numbers? So 63 or lower is significantly low. 87 or higher is considered significantly high. And any test score in between 63 and 87 is not significant. So an 84 falls in between 63 and 87, so that score is not significant. What that's saying is an 84 is not more than 2 standard deviations from the average.